equal to say 2. I'm not writing the units at this moment also. So I can always plot this particular point here on the diagram, which shows a pressure which is equal to 1 and a volume which is equal to 2. So this shows the state of the system. This is the state of the system. They are state variables of the system. Properties of state variables means with the help of which I can identify or I can plot a particular state of the system or the substance which is there in the system actually. Now when I say properties, this could be of two types. One is the intensive and other is the extensive properties. So intensive is those properties which are independent of the mass. For example, pressure and temperature. So pressure and temperature are two intensive properties. Now, and extensive properties, what are those extensive properties? Extensive properties are mass, volume, energy, etc. These are the extensive properties. If mass is increased, the value of the extensive properties also increase. So let us try to understand what is the meaning here. Okay, first I will try to explain you the meaning of intensive and extensive once again. For example, I have a big room. Let us say this is a room here. Okay, this is a room and there is air inside this room. Now let us say this air is at a pressure of 1 bar and let us say its temperature is 30 degrees Celsius. So pressure is 1 bar and temperature is 30 degrees Celsius. Now what I do is I do number of partitions here. I have made number of partitions here, and now what I do is I check the pressure and temperature in each of the partitions. So I check the temperature and pressure here. I find that the pressure is 1 bar and the temperature is 30 degrees Celsius. I take any other partition, I note down the pressure and temperature. I find that it is 1 and 30. So that means, it means pressure and temperature are such properties which are independent of mass, whether I am taking the system as a whole or whether I am doing number of partitions in the system. This property is not going to vary. Okay, so it is independent of the mass. So that is why a intensive property is independent of the mass, and pressure and temperature are intensive properties. So there can be, it's not only the pressure and temperature which are the intensive properties, there can be more intensive properties also. Okay, and what is an extensive property? An extensive property is which is dependent upon mass. So for example, if I have, let us you must have studied enthalpy. H, small h, this is known as enthalpy, or rather if I will say, it is not enthalpy, it is specific enthalpy. Okay, specific enthalpy, and the units for specific enthalpy is kilojoules per kg. Okay, so it is divided by kgs, so that means small h shows specific enthalpy because it is dependent, it is independent of mass. It is the value is for 1 kg of the mass. So whenever we are talking about 1 kg of a particular substance, and if we are calculating the enthalpy, it will be specific enthalpy. But if I have to calculate the term H, now this term H is actually, I will not call it as specific enthalpy, I will call it as enthalpy, and it is equal to M into H. M into H means the mass of the substance multiplied by its enthalpy. So when I multiply M and H, the unit for the enthalpy will come out to be kilojoules rather than kilojoules per kg. So now this enthalpy is the extensive properties, whereas the specific enthalpy is intensive property. So once again, see, intensive properties are independent of the mass. So they do not depend upon the mass of the system. For example, pressure and temperature. Whereas when I talk about the extensive properties, they are dependent upon the mass, they are related to the mass, they increase when the mass of the system increases. So if the mass is increased, the values of the extensive properties also increase. So that you have to keep in your mind. Now, we can also define specific and extensive properties.
Excuse
When
me,
I put,
sir, I have a question.
yes, tell me.
You are saying temperature and pressure are not extensive properties. They are independent of the mass of the gas. In this case, if it
Hmm.
is the gas that we're considering, not so.
Hmm. See,
Um, but am I correct?
yes, pressure and temperature are intensive properties. Now, what is your question actually?
Okay, so my question is, suppose you have say 20 grams of air
Hmm.
in a flask, and then you've locked for that air in that particular flask, and then you've been able to tell using a pressure gauge or something the amount of pressure that the air is exhibiting in the flask, and also its temperature you've measured, and then you release a bit of air from some you reduce the mass, you take out some air molecules from the flask. Is the pressure and the temperature going to remain the same?
Hmm. Okay. So that's your question actually. Okay. Now, quite simple actually. Actually, now what happens? See, for example, your question is, I got your question. See, you want to say that this is a flask and it contains 20 grams of air. Okay, it contains 20 grams of air at pressure P and temperature T. Okay, now this flask has a particular volume also. Okay, this flask has a particular volume. No doubt, when you will remove certain amount of the mass of the air from here, no doubt its pressure will change. Okay, and the temperature may also change. But what I am trying to say is, just try to understand it. See, this is how I am trying to consider it. If I do the partitions of this flask, number of partitions, okay, see the mass is, now what will happen to the mass? See, when you say 20 grams, if I do five partitions, so 4 gram of the air is here, 4 gram of air is here, 4 gram of air is here, 4 gram is here, and 4 gram is here. Okay. Now for each 4 grams of this air, if you will measure the temperature and pressure in each of the partitions, will it vary? It will not vary. Okay, it will be same. You can use different pressure gauges, you can use different temperature gauges for each of the partition, and you will find that the pressure and temperature are same. Okay, that is why I say that uh, that the pressure and temperature have intensive properties. Okay, but if you talk about the enthalpy, okay, if you talk about the enthalpy, suppose H. So if you take this particular partition and you take all the partitions, so if this partition, only this particular partition, the upper partition, if this enthalpy here is say 2, and there are 5 such partitions, so what will be the total enthalpy? So I will multiply 2 and 5, so it will be 10. So the moment the mass is increasing, the enthalpy is increasing actually. So enthalpy is actually an extensive property. Okay, so that is what I wanted to tell to you people. Now, one more thing. When I say specific extensive properties, okay. So specific extensive properties means extensive properties per unit mass are intensive properties. Example: specific volume, specific energy, density, etc. So try to understand the concept here. What is the meaning here? The meaning is quite simple. That suppose you have volume, okay, and you divide it by mass. So what is the unit for the volume? Volume is meter cubes, and when you divide it by mass, you are getting a unit which is equal to meters cubes per kg. So volume is actually dependent upon the mass. Okay, so if you keep on increasing the volume, the mass will also increase, but you have to keep the pressure and temperature constant for that particular case also if you are increasing the volume. Okay, so if you are calculating some quantity per unit mass, then it will become the specific extensive property. And a specific extensive property is actually intensive property, because the unit itself says it is meter cubes per kg. So whenever there is per kg comes in the denominator, it becomes an intensive property, because now it is independent of the mass. Okay, And one more thing, so you can see it here. If I take this particular formula, so v will be equal to m into small v. So you can see it here. So this is the intensive prod, small v, you are multiplying it by the mass, and then it becomes the total volume v. So v is the extensive property, this is extensive, small v is the intensive property, okay, and m from is the mass. When you multiply the intensive property by the mass, it becomes the extensive property. So every extensive property, when you divide by the mass, it becomes specific extensive property, and you can also call it as intensive property. So once again, I will tell you that if suppose we have some capital letter like u we are using for the internal energy. Okay, this u will be equal to m into small u. Now this small u is specific internal energy, and the unit for specific internal energy is kilojoules per kg. The moment you multiply it by mass, for which the unit is kg, kg and kg cancels out, and u comes out to in kilojoules. So u is the uh, extensive property. Okay, internal energy is extensive property, whereas small u, when I say small u, it is intensive property, or you can also call small u as specific extensive property, or specific a specific internal energy. Okay, okay, is it clear? Okay, now let us proceed to point number 6. When all the properties of a system have definite values, the system is said to exist at a definite state. Okay, so for example, if you know the pressure and the volume, so there is a particular state of the system, so a is showing a particular state. Okay, any operation in which one or more of the properties like pressure, temperature, or volume of the system changes, it is called change of state. So suppose this is the volume here, this is the pressure here. Now the volume and pressure changes such that the system has now this new pressure and temperature, then this is the new temperature and pressure, this is the new temperature and pressure. So all these are different states. So this is a particular state, this is another state, okay, and this is another state. So there are different states the system is going through. So when the state of the system is changing, then it is known as the change of the state. And then the succession of states passed through during a change of state is called a path of the change of state. So once you know that what are the changes in pressure and volume, suppose the system was initially at this particular point, then it moves to this, then moves to the next point. So that means we are defining the path through which the system is passing. Okay, and if I join all these paths, then all these states rather, then I know the path of the process, then I know the path of the process. So once the path is known, I can define the process also. Okay, so when the path is completely specified, the change of the state is called the process. For example, a constant pressure process. So it means, suppose if I take this as the PV diagram here, if this is the initial state and then the system is moving like this, moving along this particular path, so you can see the pressure is going to remain constant, so it is a constant pressure process. If I am going vertically downward or vertically upward, the volume will remain constant, so it's a constant volume process. If I want to keep the temperature change, the process would be something like this. So this is temperature is equal to constant, also known as the isothermal process. Constant pressure process is known as the isobaric process. Constant volume process is known as the isochoric process. And there are two other processes. They are known as adiabatic process, adiabatic process, and the next one is the polytropic process. I don't know whether you know about this or not, but adiabatic, polytropic, isochoric, isobaric, and isothermal. These are the various processes. Isochoric means volume is equal to constant. Isobaric means pressure is equal to constant. Isothermal means temperature is equal to constant. If you talk about the adiabatic process, we take the relationship PV raised to power gamma is equal to constant. Don't worry if you don't know it or don't remember it. We will talk about it later on. Polytropic processes PV raised to power n is equal to constant. When I say adiabatic process, in this particular case, the value of heat transfer is zero. Value of heat transfer is zero in case of an adiabatic process. So these are the various processes, and a thermodynamic cycle is defined as a series of state changes such that the final state is identical with the initial state. So that means if I am starting from point number one, and if I am moving along this particular path, if I go up to this particular point two, okay, and from point two I return back to point number one. So the system has completely followed a particular cycle. Actually, when you are starting from a point number one, going to some other point two, and then coming back to the initial point one, then the system has completed the one complete cycle. Okay, so in a thermodynamic cycle there won't be any change in the property value. You can see there won't be any change in the property value. If this is the diagram, if I am starting from this particular point where the system is following a particular cycle, then if I am moving along this particular path, then the system is completely following the cycle. So cycle actually. So these are basic concepts. You need not worry much about this. Let us proceed to the next topic. Next topic is thermodynamic equilibrium, and this is very, very important. Thermodynamic equilibrium. In thermodynamics, equilibrium plays a very major role. So let us try to understand what is the equilibrium. System from the surroundings, and you
Can't
find
hear you.
and and you don't find any change in any of the properties, then we will say that the system is in thermodynamic equilibrium. Okay, so let us see what are the various things in it. An isolated system always reaches in course of time a state of thermodynamic equilibrium and can never depart from it spontaneously. Therefore, there can be no spontaneous change in any macroscopic property. Okay, forget about this. Now uh, let us read here. Okay, this is important. This definition. This is the definition of the thermodynamic equilibrium. A system is said to exist in a state of thermodynamic equilibrium when no change in any macroscopic property is registered if the system is isolated from its surroundings. Now, what is the meaning actually? A system will be in a state of thermodynamic equilibrium if the conditions of the following three types of equilibrium are satisfied. Now, what are these three types of the equilibriums? Let us see those. There are three types of the equilibrium. One is the mechanical, second is the chemical, and the third is the thermal equilibrium. So, if you follow, if a system is following all these three types of the equilibrium, mechanical, chemical, and thermal, then we will say that the system is in thermodynamic equilibrium. Now, what is the meaning of these three individually? Let us discuss about that. In the absence of any unbalanced force within the system itself and also between the system and the surroundings, the system is said to be in a state of mechanical equilibrium. If an unbalanced force exists, either the system alone or both the system and the surroundings will undergo a change of state till the mechanical equilibrium is attained. So basically, what does it mean to say is, for example, suppose the pressure here is 2 bar and the pressure outside is 1 bar. Okay, what will happen? Do you think that this piston will not move outward? It will move outward. It will move outward till the pressure here falls to 1 bar. And at this particular moment, when the pressure will become equal between the system and the surroundings, then we will say that the system has come to the mechanical equilibrium. System has come in the mechanical equilibrium because there is no variation in the pressure within the system and the surroundings. Okay, so within the surrounding has the same pressure and the system has the same pressure. Okay, at this moment the system is said to be in the mechanical equilibrium. Now what is the chemical equilibrium? If there is no chemical reaction or transfer of matter from one part of the system to the another part of the system, such as diffusion or solution, the system is said to exist in a state of chemical equilibrium. So no chemical reaction, this is the first condition, or no transfer of matter from one part of the system to the another part of the system, such as the diffusion or solution, the system is said to exist in a state of chemical equilibrium. Okay, so once there is no chemical reaction going on, that means the system is in the chemical equilibrium. And when the system is existing in mechanical and chemical equilibrium, is separated from its surroundings by a diathermic wall. Diathermic means which allows heat to flow. And if there is no spontaneous change in any property of the system is said to be exist in a state of thermal equilibrium. Basically, it means that if this is the system and if the temperature here is 30 degrees Celsius and outside also it is 30 degrees Celsius, so when both the temperatures are same, there won't be any transfer of energy Q here or there. Okay, so Q will be equal to zero. So there is no change in the temperature, then it is known as the thermal equilibrium conditions. So when the system is following the three conditions of the first one is the mechanical equilibrium, the first one is the mechanical equilibrium, the second is the chemical, and third is the thermal equilibrium. When it is following these three equilibrium conditions, then the system is said to be in thermodynamic equilibrium. Okay, now this is the last topic for today. I think 3 minutes are still remaining, so I can discuss a few things about it. Cauchy static process. Okay, do you have any other class after this?
Yes, we have two classes.
Yes, sir.
After this, okay, then I
Yes,
will.
we have
Okay, so I will leave you here. This we will discuss in the next class. Okay. So if you have any questions, you can
All right,
ask.
sir.
Hello, sir.
Yes.
Yeah, I have a question and a clarity for you pertaining to the assignment one you sent on our emails. You said we should read in our handwriting thermodynamic definitions or the application of thermodynamics, etc. Then to send a soft copy to you. So how will we send a soft copy to you? Is
Uh,
it in the class in the chat room or
can you write your question in the chat box?
okay, me ready.
Okay.
Okay, sir.
Because sometimes, yeah, you tell the question, I will answer either on the WhatsApp group or here.
Teacher, I have a
Ye-
question.
Yes.
If we have an exercise
If we have.
and if we have
Mm-hmm.
an exercise, they will tell us that the 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 energy is constant. They will
In which case,
precise. They will precise. They will precise that the pressure or the temperature is constant.
in which case you are talking about?
In 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 uh, in the pressure
Mm-hmm.
in the pressure and the temperature they will tell us that it's they are constant or not? If we have
Can
an
you write the
exercise.
question? Because I am not getting you. What question you want to ask? If you write the question here, I will answer it
Okay.
in the chat box.